Right, how are you guys? Mr. Exact is back. In this family, we do not believe in stingy people. Just tell someone, say something about our channel, recommend our channel to someone so that our channel will grow. Right, in this tutorial, we're going to talk about it, how to solve simultaneous equations using elimination method, using substitution method. Right, in one video, we are going to do it quickly using this example. So let's go get it. Elimination method. Elimination method. Alright, suppose let's want to solve this equation. That's 2x plus 3y plus 5 equals to 0. 3x minus 2y equals to 12. So the first thing is we must rearrange our equations. In simultaneous equations, normally we do have letters or unknown terms on one side of the equal sign, the constant values on the other side of an equal sign. So in this equation, as you can see, the first equation, we need to regroup 5 to the other side of the equation of the equal sign. So we regroup it into 2x plus 3y equals to, this was positive 5. So when we move to the other side, it becomes negative 5. That's our equation 1. Then equation 2 is find 3x minus 2y is equals to 4. This is equation 2. When we are using elimination method, bear this in your mind. We cannot handle two letters at the same time. So we need to get rid of one of the letters. That's elimination. Usually we eliminate the first, the letter which is on the left hand side, this first letter. For instance, let's get rid of x. We want to eliminate x. But in order for us to eliminate letter x, the coefficients of x must be equal. That's the first thing that we must do. So to make these coefficients equal, we need to cross multiply both the equations by the coefficients of x. For instance, in equation number 1, the coefficient of x is 2. This coefficient will multiply by equation number 2 up to the end. So you multiply by 2. Then in equation 2, the coefficient of x is 3. So you multiply by 3 up to the end. Right, so let's do that. 3 times 2. Take note, we are not using 3x. We are just taking the coefficient, the letter, the number, not the letter. So it's 3 times 2x, we get 6x, plus 3 times 3y, we get 9y, equals to 3 times minus 5, we get minus 15. 2 times 3x, we get 6x. 2 times minus 2, we get minus 4y. Then 2 times 12, we get 24. Now, look at this. The coefficients of x are now equal. That was our target. We wanted to make sure that x have equal coefficients. So to do this, we cross multiplied the coefficient. Coefficient 2 was multiplying all the terms in equation 2, then coefficient 3 here multiplying all the terms in equation number 1. Now, we want to get rid of x. You check if the x values have the same sign. If they have the same sign, you subtract. But if they have different signs, for example, if this was minus and this is positive, we're supposing to add. That is 6 plus minus 6, then you get 0. So it's very important to take note of that. If the numbers to be eliminated are of the same sign, you subtract. Even if they were both negatives like this, if it was minus 6 and minus 6, to eliminate x in this case, you need to subtract because they go with a similar sign. That is, you subtract minus 6 minus minus 6, it becomes 0. If we add in this case, x will not be eliminated, we will get negative 12. So our original question was 6x and 6x, so we're going to subtract 6x minus 6x out. 9 minus minus 4. Take note, it's 9 minus minus 4. we have 2, we have double negatives here, 9 minus 4, so we are going to add, it becomes positive 13y equals to minus 15 minus 24. We have minus 15 minus 24. We are going to add and get a negative as 5 plus 4, 9, then 2 plus 1, we get 3. So the answer is minus 39. Now we need to get rid of 13, so we get the value of y. And we're going to divide by 13, both sides over 13. 13 to 13, get y equals to 13 into negative 39 is negative 3. Now take note, since now we know the value of y, we can easily find the value of x. You go back to any of the original equations, that is before cross multiplying coefficients. For instance, we are going to take equation number 1, 2x plus 3y equals to minus 5. In place of y, we are going to write down negative 3. That is 2x plus 3. 3y implies multiplication. So 3 and y, they are multiplying, so you open bracket. Instead of y, we are writing down negative 3, the latest answer. Then we get minus 5. Now 2x, 3 times minus 3, you get negative 9. It's always very important to handle directed numbers with accuracy. Finally, by grouping, negative 9 when grouped to the other side becomes positive 9. 2x is equals to minus 5 plus 9. You are going to subtract and get a positive 4. Then we divide by 2 both sides, and x is 2. Simultaneously, through elimination, we got to know the value of y and the value of 2. So that's elimination method. You simply make sure that the coefficients are equal, the coefficients of the equation to be solved. For instance, equation number b, let's say equation number b, we are going to learn something in this question. Equation number b is 3x plus 2y is equals to minus 14. 3x minus 5y is equals to 56. Alright, if you closely look at this question, the x values already go with an equal coefficient, meaning to say there is actually no need for us to cross multiply the coefficients, because the reason why we were cross multiplying the coefficient, we wanted the coefficients of x to be equal. So if they are equal already, we simply start by eliminating x, either through addition or subtraction. In this case again, the x values are of the same sign, they are both positive. So in order for us to eliminate, let's subtract. Now we are subtracting every column until the end. 3x minus 3x out. 2y minus minus. It's 2 minus minus 5. 2 minus minus 5. So we add, we get 7y positive. This one. Get positive 7y is equals to minus 14 minus 56. Alright, so this one now implies that we should add these terms. So let's add 14 to 56, but we'll get a negative answer. 6 plus 4, 10, 0, 0, 1, 5, 6, 7. So we get negative 70. It's always advisable that you must be able to handle directed numbers with accuracy before you try any other topics in mathematics. Check with our tutorial number 1 on our channel, the Exact Academy, where we're explaining easier methods of handling directed numbers or negative signs. Now, let's divide by the coefficient 7 so that we will get to know the value of y, and we get negative 10. When we get to know one of the letters, now we can go back to one of the equations to find the other unknown, and the other unknown term is now x. So you choose among these two and one of the equations, then you substitute. 3x plus 2y is negative 14. I chose equation 1 with smaller numbers that I can end with easy. Now y was minus 10. So we are saying 3x plus 2. In place of y, we are taking negative 10 is equals to negative 14. Then we get 3x, 2 times minus 10, we are going to get negative 20 is equals to negative 14. And now 3x is equals to minus 14. This negative 20 will become a positive. And 3x is equals to minus 14 plus 20. We subtract and get a positive 6. Then we divide by 3. And x is equals to 2. Y is minus 10, x equals to 2. So this is elimination method. If the equation involves fractions, you must multiply every term by the common denominator first to clear fractions. Suppose the equation goes with the decimal numbers. Let's say we are asked to solve 0,2x plus 3y is equals to 1,2 x minus 0,5y is equals to 2,3. Right, it's still simultaneous equation, but now it involves decimals. We have the easier way we can handle this one. You check the number of decimal places. In the decimal numbers, we only have one number after the comma, one number after the comma. So we can actually zoom the numbers 10 times. We multiply every term by 10 so that we get rid of the commas. That is multiplied by 10 multiplied by 10. 0,2 multiplied by 10, it becomes 2x. 3 times 10 becomes 31 equals 1,2 times 10 becomes 12. Then x times 10 becomes 10x minus 0,5 times 10 we get 5y is equals 2,3 times 10, 23. Then from there you do cross multiplication of coefficients and you using elimination method. So quickly, let's move on to another method. The other method, number 2, is substitution method. Normally in exams they do not force you to choose or to be strict to use one specified method. They simply ask you to solve a simultaneous equation. So you must have at least one method you are comfortable with, either substitution method, elimination method, matrix method, or graph method. So now let's go through substitution method. This method has one disadvantage. It is sometimes not applicable fully. We can only efficiently use the method if among the coefficients we have one of the terms with coefficient 1. For instance, if you check this equation, 4x plus 3y equals to 6, coefficient of x here is 4, the coefficient of y is 3, and in this equation number 2, x is coefficient 1. In such a situation, it will be very easy to use substitution method. Let's go and check how do we do that. 4x plus 3y is equals to 6. X plus 2y is equals to negative y. So I'm saying substitution method is most applicable when one of the unknown or the letters have coefficient 1. If suppose this x had a coefficient more than 1, for instance 2, it was going to be a bit complicated for us to use the substitution method. So before you use substitution method, you must check if one of the letters stands on its own or have coefficient 1. Alright. So in this equation, we can safely use the substitution method because we have x here with coefficient 1. So first step, you name the given equation, that is equation 1 and equation 2. We encourage you to use Roman numerals because if you use digits like 1 and 2, you might end up making a mistake, becoming 61, and this will be 12. So Roman numerals are advisable. That was our first step, naming the equation. Then secondly, you create or you formulate equation number 3. How do you do that? You form equation number 3 through making that letter with coefficient 1 a subject of formula through grouping method. So x will remain on the left hand side. X is equals to minus 1. Then let's regroup this 2y to the other side. It was positive 2y, it will become negative 2y. Now we made x the subject of formula. And equation 3 is reading that x is equivalent to minus 1 minus 2y, which means we can replace x by this number. To substitute is to remove and replace. So that's why the method was called the substitution method. Now we are going back into the other equation, equation 1. In place of x, we will write down this one. If you substitute this answer into the equation 2, sometimes you don't get a correct answer. So you must substitute it into the other equation, which is not the one we used to make equation 3. So we do better start by writing down this equation as it is. 4x plus 3y is 6. But now take note, this x, we know the other value of x. X can be minus 1 minus 2y. So 4x means multiplication. So we are saying 4 multiplied by the bracket of minus 1 minus 2y, representing this x. Then we continue, plus 3y is equals to 6. Let's remove brackets. 4 times minus 1 minus 4, 4 times minus 2 minus 8y plus 3y is equals to 6. And simple. Now we are having a linear equation. Let's use grouping method to solve the equation. So minus 8 will remain on the left hand side and plus 3 is equals to 6. Let's move minus 4 to the other side. It will become positive 4. Minus 8y plus 3y, we will get minus 5y. Minus 5y is equals to 6 plus 4, we will get 10. We reach this level, minus 5y is equals to 10. So we divide by negative 5 both sides. And y is minus 5 into 10, get minus 2. Now we know the value of y, and we need to also to know the value of x. The last step, the easiest way is you go back to the new equation, the equation 3, x equals to minus 1 minus 2y, and substitute your latest answer. Since now we know that y is negative 2, so x is equals to minus 1 minus 2. In place of y, we replace it by negative 2. And we have x is equals to minus 1. Minus 2 times minus 2, we get positive 4. So x is equals to minus 1 plus 4, we get 3. That's the substitution method. It's most applicable when one of the letters is coefficient 1. In this situation, you can still do, but it is complicated because it involves fractions. In other words, that's the first two methods of solving simultaneous equations. Let me show again matrix method. How to use matrix method. Let me create a space here. Matrix method of solving simultaneous equations. And our number is 078205443Y. This is our EcoCash account where you send through your tithe. Donate to our school. That's my WhatsApp number. We can also add you to a WhatsApp channel, and we can actually mark some work on this platform. You write down your homework, then you send through it on my WhatsApp platform. I'll assist you there. Alright, we have another method of solving simultaneous equation called matrix method. But I advise that before you go through this method, you must be well vested or equipped with the topic called matrices. Check with other tutorials that I posted. We covered on the topic matrices, because we are now combining two topics in solving this type of equation. Let's say we are going to solve the equation number C using matrix method. The equation is 2x plus 3y equals to, we regrouped this one to the other side, so it becomes -5. Equation 1. Then 3x minus 2y is equals to 12. That's equation number 2. We want to use matrix method. So the first thing, you create or you come up with matrices of coefficients, the coefficients given in this equation. I'm going to create a 2 by 2 matrix of coefficients only. That is, the coefficient of x here is 2, the coefficient of y is positive 3, coefficient of x is 3, coefficient of y is -2, like that. Afterwards, you create another 2 by 1 matrix of unknown terms in their alphabetical order. So we start with the x followed by y, then equals to, on the other side, you write down the constant values, that is -5 and 12. That's our first step. You create matrices. After that, on this left hand side, we want to remain with only this matrix of unknown terms. The other matrix should be moved to the other side. But when we are entering multiplication of matrices here, we cannot directly group this matrix to the other side because they are multiplying. So instead, we need to find the inverse of this matrix. So the first thing, we are going to calculate inverse of the matrix. And in order for us to calculate inverse, we need determinant. So let's find the determinant of this 2 by 2 matrix. Determinant equals to, we say, numbers in major diagonal, they multiply. That is 2 times -2, subtracting numbers of off diagonal. That is 3 times 3. 2 times -2 get -4, -9. And the determinant is -13. How about the inverse? Inverse of the matrix is 1 over the determinant -13 multiplied by this matrix. But now, numbers in major diagonal or main diagonal will exchange positions. That is -2 and 2. Numbers in off diagonal, they are multiplied by -1, or will simply change their sides. If it was +3, it becomes -3, another one -3. This is the inverse of the matrix. Now, since we have the inverse, we are going to multiply both sides by the inverse. Both sides by the inverse. But according to our understanding of matrices, if you multiply a matrix by its inverse, it will give you an identity matrix 1, 0, 0, 1, of which it will bring no change to this one. So simply ignore the information I was giving in terms of multiplying by inverse. Simply get this shortcut. You will find the determinant and the inverse. Afterwards, you cancel this matrix. Then you remain with a matrix of unknown terms, that is x1 is equals to. On the other side, instead of start by writing down a matrix of constant value, start with this inverse. That is 1 over -13 multiplied by -2, -3, -3, 2. Then you bring down this one, -5, 12. It's a shortcut that I used there. So step by step, first thing, you break down the equation into matrices. After that, you find the determinant and inverse of the 2 by 2 matrix of coefficients. When you get the matrix, on the left hand side, you remain with a matrix of unknown terms. Then you move the inverse to the other side. You start by the inverse, followed by the matrix that was already on the right hand side, like this. Now, we are closer to the answer. The statement is saying the value of x and y can be found through solving this problem. We have scalar multiplication, 1/30 should multiply by these terms, and we also have general multiplication. These two matrices are multiplying. So the order of combined operation there is you start by multiplying these matrices first, then you conclude with scalar multiplication. So now I'm erasing this side to get more space. Alright, x is equals to 1/-13 minus 2 minus 3 minus 3, 2, then minus 5, 12. Alright, all this was xy. Now the first thing that we are going to do is we are going to focus on the general multiplication. We are multiplying these matrices first, and we will get minus 2 minus 3 minus 3 minus 2 is multiplying by minus 5 and 12. This is a 2 by 2 matrix, 1, 2, 1, 2, multiplied by another 2 by 1 matrix. It is possible to multiply. If you do the other way around, starting with this one, we get an impossible multiplication. And the answer is going to be a 2 by 1. So let's multiply row by column. Minus 2 times minus 5 plus minus 3 times 12. Then this one minus 3 times minus 5 plus minus 2 times 12. Then we get minus 2 times minus 5 get positive 10 plus minus 3 times 12 we get minus 36. Minus 3 times minus 5 we get positive 50 plus minus 2 times 12 we get minus 24. And the final answer is 10 plus minus 36. We are going to subtract here. It's 36 minus 10, but we get a negative answer, that is negative 26. Again, we are subtracting here. 15 minus 24, that's 24 minus 15. But at the end, we get a negative answer. 14 minus 5 is 9, 2 minus 0. So we get negative 9. If I'm not mistaken, 15 minus 24 is minus 9. Now, let's go back to our question with this answer. The equation reads that x, y is equals to 1 over minus 13 multiplied by this matrix. So these two matrices, they brought us this answer. I guess I did a mistake somewhere. 15 plus minus 24. 24 minus 15. 14 minus 5. You get 9. Anyways, I suspect that I did a mistake somewhere. Right. 1 over 13 is now multiplying by this answer, minus 26 and minus 9. Then finally x and y is equals to this 1 over 13 is a scalar. A scalar must multiply by all terms inside the matrix. That is 1 over negative 13 multiplied by negative 26. And also 1 over negative 13 multiplied by negative 9. I suspect that I made a mistake somewhere because we once solved this equation and we got all numbers. But as I'm checking this one, we'll get a fractional answer. But otherwise, that's how we use matrix method. You will trace where I made an error. Minus and minus, they cancel. 13 to 26, we get a 2. And x was 2 when we solved this equation. but the working that is leading us to negative 9, somehow I made a mistake. Let me check here. Minus 3 times minus 5, you get to 15. 2 times 12, you get to 24. Okay, that's where I made a mistake. It's 15 plus 24 instead. 15 plus 24. 4, 5, that's 9. And this one, 39. Instead of 9, should be 39. It's good. You must feel that you made a mistake somewhere. So it should be 39. Anyways, 5. Minus 13 into 39, we get minus 3. And now we have equivalent matrices. When two matrices are equal, it means corresponding values are equal. So x is equals to 2 and y is equals to minus 3. Yeah, mathematics is a discipline that teaches you to maintain accuracy. So if you go wrong somehow, you must feel it in yourself that else. You suspect something, then you trace and get the answer. I liked how I made an error and traced the error. It's a lesson that you should also pick up. In mathematics, you need to maintain accuracy. If you go wrong somewhere, you must feel it, you must detect it. So this is how you solve simultaneous equations using the first 3 methods. Maybe for someone to fully understand, let me quickly show again another equation. We are taking equation number B. 3x plus 2y is equals to negative 14. 3x minus 5y is equals to 56. Right. So we are going to break down these two equations into a matrix of coefficients 3, 2, 3, minus 5.